Okay, in this video, we're gonna learn HDFS high availability. In short, we call it HA, sometimes called HA. So what's the problem? Um, there's a concept called single point of failure. Okay, in HDFS, imagine the structure is configured. You have one name node in charge of everything, and you have so many data nodes following the directions, whatever the name node tell them to do. Okay. In order to disable your HDFS cluster, I can simply shoot the name node. Okay. Even though you have 200 data nodes, they're all following the directions from name node. If I shoot name node, your whole cluster is disabled. Okay, so your whole cluster, there is a single point of failure. That is the name node. If your name node fail, your whole cluster is not available. Okay, so HDFS, this is a problem. HDFS high availability, HA, is designed to protect the name node. In case name node fail, how your cluster still remains in service. Okay. Single point of failure as a concept. Okay, we should know. So how to solve the problem? We simply make backups, right? As everybody knows. How do we make the backup? There's multiple ways. Okay, it depends on how fast you want to recover. Imagine that I am the name node, okay? I manage 200 data node. They're all listening to my directions. And at any single moment of my working, I'm maintaining a lot of information in my memory. I know of the 200 data node, who is available, who is busy, how many available space of each one of them. For any file under my control, what are the block? Where are they located or saved among the 100 names? So in my memory, there's a lot of things going on. But at any moment, there's data. There's a file has been saved. There's a file has been read out. So I'm a pretty busy person, a pretty busy node. How to make backup of everything I've done? That is not an easy job. Okay. One way is to write logs. Okay. So everything I've done, I write down it and put it aside. Every time I've taken action, I make a log and save it. Okay. And then if somehow I failed, okay, in my work, and someone I'm gonna come here and replace me, the person comes in and take back all the logs I've written and read one by one and try to restore the status before I failed. And the other name node can resume my work. That's one way. As you can imagine, that's gonna take a while. If a new person comes in, try to read my log and try to restore the status, it's gonna take a long time. Okay. But that's not satisfactory in terms of we want to have a 24/7 HDFS system. We don't want to have downtime. Another way to solve the problem is that I have a live assistant who just simply sit next to me and watching what I've done. For everything I have done, my assistant just do the same thing. So at any moment, my assistant or my single copy node just maintain exactly the identical status of me. Whenever somehow I failed, my assistant can instantly resume my work. Okay, so that is that is the design of HDFS high availability, HA. Okay, a pair of name nodes in an active standby configuration. So at any moment, there's only one name node is active. Okay. If I'm the active name node, I'm in charge of the 200 data node. The standby name node maintains the same status, identical to me, but is not participating in any management tasks. Only in case the active name node stopped working, then the standby name node can resume the work. Okay, that's the high availability design. There's a technical implementations. QAM is a commonly used mechanism. If you're a HDFS administrator, you just know what it is. Okay. From an administration perspective, you don't have to know how exactly it works. You just know how do I use it. Okay. Who need to know how exactly QAM works? The people who need to maintain, who is developing HDFS, who is maintaining HDFS, okay, patching, then those persons need to know. Okay. Subsequently, we have the failover and the fencing concepts we need to talk about. Okay. Failover. In the event of a name node failure, how the HDFS system recover. This mechanism is called failover control. Okay, failover control. As I said, HDFS is a complicated system. Name node is very busy, managing so many things. It's very complicated. This is not a simple task. Okay. So how it works? Default failover controller is called Zookeeper. Okay, Zookeeper again is a maintenance, not maintenance. It's one component of Hadoop to help a Hadoop class to recover from a failure. Okay. Okay, there's a mechanism. First, very importantly, is that the whole HDFS or in general Hadoop cluster need only one name node. That's like if in a classroom, if there's two instructors and they're not cooperating well, they each want to issue different commands to students, then it will be a chaos. So in any working system, there should be one commander or central commanding office. Okay, supposed not to give different directions. In HDFS, we only want to have one name node. Okay, whenever that node needs something, it go to only one place. So failover control, want to make sure there's only one name node that is working. Before we go to how the working mechanism, we want to learn a term called graceful failover. That simply means the failover is not because of incidents. It's because the system needs to restart because of maintenance. Okay, the maintenance people need to upgrade version or upgrade a memory, CPU, hardware, software. They need to put it in a restart system. That's a maintenance. That's a graceful failover because they want to make the system better, not because of incidents. Okay. Then the last concept is called fencing. Fencing is a mechanism of a failover. Okay. The fencing method works because it want to keep only one active name node. Okay, let's look at the failover event. So I have two name node, okay? Name node 1, name node 2. Name node 1 is active name node. The active, and this second one is a standby, active standby. In a normal case, the active name node is managing all the date nodes, trying to name date node, very busy, but works fine. In the rare case, the name node somehow failed. They said, well, I cannot work anymore, as it failed. And then all the other date nodes were panicked. We said, well, our master is not responding. How are we gonna work? But the standby name node also noticed that. Standby try to knock the door of the active name node and say, hey, what's going on? And try to keep knocking. And I standby name node find out, okay, this guy's probably gonna fall asleep for a while. And I make a decision, I need to resume the work, okay? But when the standby name node start to resume the work, we do not want the dead or sleeping name node suddenly wake up, because when they suddenly wake up, there's two name nodes. That's gonna be a troublemaker, okay? So when the standby name node already made the decision to say I decided to resume the work, at the same time, this guy must keep a fence on top of this one. They say, I decide to resume the work, now you have to keep shut. Even though you wake up, you have to stay there, don't become active. This mechanism put a fencing on the sleeping named or failed name is called fencing, okay? When you understand all this, and you have very good understanding about the failover control, okay? So this is it.